This presentation is about design for the environment. Design for the environment is a type of concurrent design. We concurrently consider all the cradle-to-grave environmental impacts of a product or service concurrent with product design. So in other words, at the time when we're designing a product, we think about what is the impact going to be of sourcing materials or other resources that are required to make it, the actual act of making it or creating it, if it's a service. What are the environmental impacts going to be when the user is using it? For example, the environmental impacts of driving a car are very significant. And then what are the impacts at the end of life? What's going to happen to it if it goes to a landfill? Can it be recycled? Things like that. This is a really important concept because the majority of the environmental impacts of a product or service become fixed at the design phase. It's very well known that when it comes to financial cost, the majority, and I mean like 55% or more, of the costs of producing a physical product becomes set during the design phase. When the design phase is over, it's too late to change them. And the same thing is often true with environmental impacts. So we need to think about the entire cradle-to-grave impact of the product or service that we're designing when we're designing it. We don't want to wait till the product's been designed or produced, for example, to start thinking about what are we going to do with it when it's at the end of its useful life. You can see here just from this picture that some manufacturers' packaging is recyclable. We can't really see them because they're in the container, and clearly some is not. So before we talk about specific design for the environment principles, let's just talk a little bit about end of life. So at the end of a product's life, we can do basically three different things with it, as you can see here. We're all fairly familiar with recycling and disposal, but not as much with remanufacturing. I think we have a pretty good sense of what we mean by recycling. It is important to point out that recycling is kind of a misnomer. Typically when we recycle stuff, we're really kind of downcycling it. In other words, recycled paper or pulp from recycled paper can't be used in all the same ways as virgin pulp. So a lot of times that recycled material is not as good as virgin material. So recycling is not necessarily a way to completely eliminate the environmental impacts of the stuff that we use. Something that we're a little bit less familiar with as consumers is remanufacturing, because we don't deal with a lot of remanufactured products. Remanufacturing is not the same thing as repairing. Remanufacturing a product means bringing it back up to its original state and then reselling it to a new owner. Years ago, when we still used film cameras, there were what was called disposable cameras, but really you would mail that camera in and have your pictures developed, and then they would remanufacture the camera, put new film in it, maybe put a new label on it, things like that, and sell it to a new user. Many of us know that automotive batteries are typically remanufactured. For example, in the industrial space, there's a lot of products that are remanufactured. And then there's disposal. Typically, disposal means putting something in a landfill or incinerating it, depending on the material and depending on where it happens. So here are some DFE guidelines. These are guidelines for designers that facilitate reducing the environmental impact of products and services. And I mentioned the term cradle to grave a couple of times. You can see up here at the top, some of these design for the environment guidelines are aimed at the sourcing phase, which would be, again, getting the materials and whatnot that we need to create a product or a service. Some of these are aimed at the actual creation phase. Some are aimed at the use phase. So this is what the consumer or other user is doing with the product. And then quite a few of them are aimed at the end-of-life phase. Again, that would be disposal, remanufacturing, or recycling. So let's go through and talk about a lot of these points or guidelines that are on the list. The first principle on our list is to reduce the mass and volume of materials. This is going to have an impact at the sourcing phase because there's less inbound material that needs to be transported to the production facility. If it is an item that's going to require energy to move around like a car, then certainly the less mass that we have in the car, the more fuel efficient it's going to be. And if we've used less material, then at the end of the life of the product, there's going to be less stuff to have to throw away or recycle, etc. Here's a good example that I noticed recently. You can see the differences between these two tea bags is the little tag that's got the manufacturer's name on it, the piece of string, and the little staple there in the tea bag on the upper left hand corner, kind of holding the tea bag together. Arguably they're unnecessary. Certainly as a consumer, I'm not willing to pay extra for these things. For a lot of consumers, they may not really add a lot of value. So you can see, the company down on the right has kind of thought this through, and they've made the determination that it's better to leave these out of the product. The next principle is to reduce or eliminate packaging. Sticking with our tea bag theme again, you can see some differences here in the packaging, right? On the left-hand side, each tea bag's got its own individual little package. On the right-hand side, you don't have that. So there's a difference there. Again, as a customer, I'm not sure it really makes a difference to me, and the company there on the right has determined that maybe its customers aren't interested in paying for that extra packaging, and certainly the environmental impact, if we can reduce the packaging, is going to be reduced. The difference between the third and fourth points is a little bit subtle. The third one deals with the materials, what happened to the materials before they went into your product or your service, and the fourth one deals with what happens or what can happen to the materials after your product has died or after your service has been performed. Can they be recycled after that? The fifth, select materials that are locally or regionally available, is important for social reasons, clearly, because of the ability to boost the local economy, but also for environmental reasons. For example, if we're sourcing locally, chances are we are reducing inbound material and transportation impacts, environmental impacts, and costs. It's also important to avoid using materials that could be toxic to manufacturing employees or employees that are involved in installation of a product or providing a particular service and so on. For example, sneakers, running shoes, things like that. In the beginning of the 2000s, people really woke up to the fact that there's some really nasty glues and plastics and things like that in a lot of those products, and Nike was one of the companies that kind of took the bull by the horns and decided to rethink the materials that were used and how those materials were put together, things like glues and other solvents, and they made a lot of progress reducing the use of materials that are hazardous to workers, as well as reducing waste and things like that. The name of that program was the Nike Considered program. Like a lot of environmental innovations, we really don't hear about it anymore because it also saved money and improved product performance. And now a lot of these materials are just standard practice on most shoes. Okay, so the next point that I'd like to talk about is selection of energy efficient components. Like a lot of these designed for the environment principles, this one doesn't apply to all products. It tends to apply to products where there's a significant energy usage component in the use phase. So for example, you can see here Here's the life cycle assessment for a smartphone. And you can see most of the energy use is actually during production, but the energy use during the use phase when the user is actually using the phone is not insignificant. So there could be some advantage to using lower energy components in the smartphone from an environmental standpoint and certainly from a performance standpoint. As it says over here on the right, though, as I mentioned, it really depends on the product. If you looked at a graphic like this for a refrigerator, you'd see that the bar for the use phase probably dwarfs the bars for the other phases. And in that case, if we were designing something like that, we'd want to think really, really seriously about energy efficiency if we're interested in environmental impacts. For something like a coffee cup, clearly there's no or very, very minimal environmental impact related to energy consumption of a coffee cup or while you're using a coffee cup, so it's not important at all. Okay, so our next couple of points have to do with upgrading and repair. I just grabbed this off the internet a day or two ago. With the advent of the maker movement, repairing stuff is actually kind of coming back into vogue. And if you look at this bottom of this poster carefully, you'll see that some of the things that they talk about are actually just kind of different takes on some of these design for the environment principles. Here's a screenshot of the design for the environment guidelines for Bombardier company, which makes airplanes, and I think in Europe they also make and sell other transportation related stuff or other vehicles of different types. And you can see when it comes to upgradability, some of the things they talk about are using modular design to allow for upgrading, making sure that the parts that need to be upgraded are easily identified and can be easily separated from the rest of the product, those types of things. It's really important if we're going to remanufacture a product, if we're going to design a product so it can be upgraded, or if we're going to design a product that's in any way complex and is going to be recycled, that it not be too difficult to disassemble the product. Here's an example of a pretty simple device, just a dental floss container. It's easy to open. There's no glues holding parts together, no sonic welds or other types of welds holding things together, no screws. Everything comes apart easily. And as you can see here, the parts are also labeled so we can tell what the parts are made of and so on. So a good example of design for disassembly. Here's just a screenshot of some of Hyundai's design for the environment guidelines. You can see different types of joints, adhesives, that would be glues and whatnot, welds, Velcro, bolts, snaps, etc. And they've basically rated these different types of joining materials together or joining parts together based on a number of different criteria, including their strength and things like that, but also the cost of separating them, cutting them apart, recycling them, because it's important to Hyundai that designers think about these things during the design phase. We don't normally think of shoes as being something that would be disassembled and recycled, but here's an example of a Timberland shoe called the Earthkeeper shoe that's actually designed so it can be disassembled into 4 or 5 components and then recycled or possibly even upgraded. Typically, shoes can't be recycled because even though some of the material in the shoes is recyclable, stuff is joined together, it's glued together, and so on. We've joined up, different types of materials that would need to be recycled differently, and the term that some folks use for that is a monstrous hybrid, where you've got different materials that are joined permanently, and that makes it very difficult to recycle. Here's an example of a disposable razor blade or a disposable razor. If you're making something that's disposable, an important aspect of design for the environment is facilitating recyclability. But here, if we've got 2 different kinds of plastics and they can't be easily separated, then this product is not particularly recyclable. So that's a problem. So reducing material variety and reducing glues and things like that that join different types of materials together are two important ways to facilitate recycling or remanufacturing. Another way to do that, of course, is with labeling different components, so recyclers, remanufacturers, and so on can see what those components are made of and determine what to do with them, basically, at the end of the life. Another important point is to avoid putting coatings and such on materials if it can be avoided and if they reduce the recyclability. Good example of that is wax-coated cardboard. When you coat cardboard in wax, you make it basically unrecyclable. A lot of grocery stores in the past 10 years have actually really cut down on their use of waxed corrugated. They've asked their vendors to either use reusable totes that are made out of plastic or things like that, or just switched over to the extent that they can to asking their vendors to just use plain corrugated material. Another important consideration is infrastructure, reverse supply chain. In other words, how do we get the materials back to a processing plant where we can do something with them, and then to a market, where those materials might have value as recycled materials. This can be a big issue with glass. Glass is recyclable technically, but in a lot of areas of the country, there's not really a market for that used glass. Sometimes companies create their own infrastructure if they can't use municipal recycling or channels like that to get materials back and do something with them. A couple of fairly prominent examples are Nike Grind, where Nike recollects used athletic shoes and they grind them up to make things like playground surfaces and athletic turf and whatnot. And HP's Planet Partner program, where HP has drop-off locations or mailers or whatever the customer wants to use, basically, that they can use to return their printer cartridges, and then HP uses that material to make new printer cartridges. Another important principle is to avoid using materials that can be toxic at the end of the life, that can be toxic in the landfill. And here I've just got a spreadsheet. This one is also from Bombardier, although most sophisticated companies are going to have a list like this of prohibited and restricted substances. Some of these are illegal, but many of them, it's just company policy that we're not going to use these materials because they're hazardous in some way for workers to use, or because they may be hazardous in the landfill, or they may be hazardous to the product user. For example, if an office chair or carpeting or something like that may be made with materials that off gas, that create problematic vapors and things like that for folks. So we can just wrap up by looking at some existing designs and some improved designs for a really common product that most of us use. We already looked at this graphic once. And this is from a website called Great Recovery Org, and it's worth clicking the link here and taking a little bit more detailed look at the teardown they've done of a couple of different razors. Again, disposable product, but recycling's hampered by the fact that you've got materials joined together and very difficult to disassemble. Doesn't look to me like the things are labeled. We've also got a steel blade that we would have to separate out. That probably can't be avoided. Here's some existing designs for non-disposable razors. You can see an incredible number of different parts that are used, lots of different materials. The materials aren't labeled. Sometimes the materials are joined together in ways that can't really be easily separated. So again, kind of some violations of some of the design for the environment principles. Here's a better design that the website suggests. So it looks to me like this is kind of a modular design, an upgradable design. Like a lot of razors, we can replace the blade, but but when this thing reaches the end of its useful life, it looks like it's also completely recyclable. Looks like we've only got two materials used, the same type of plastic used throughout the razor, and then we've got some steel here in the blade and some steel in this weight. It's easy to replace the blade. The steel can be recycled. The plastic can be recycled when the razor gets to the point where maybe we don't want to replace the blade anymore. Maybe the razor's just worn out. So, different design, a little bit more thoughtful design. It looks like this product is going to be just as functional as any of the other products. And because it's very simple and there's a small number of parts and there's a small number of materials that are used, it's probably a fairly inexpensive product to produce and to purchase as well. So the last important point that I want to make on life cycle assessment is that the importance of any of these particular guidelines is not going to be the same for every product, and it's going to depend on the product life cycle. We talked about that a little bit earlier when I showed you the graphic of the cell phone. For example, if we're talking about the impact of something like a disposable cup, the biggest impacts are going to be at the end of life phase of the product life cycle, and we're going to probably want to emphasize design for the environment principles that promote recyclability, that promote material reduction. So there's less stuff that we have to recycle, less stuff that we have to put in a landfill or incinerate, and so on. On the other hand, as I alluded to earlier, if we're dealing with a product that uses energy, then chances are the use phase is going to dwarf everything else when it comes to the environmental impact of the product or service, and we're going to want to focus on energy use reduction by picking the right components. If it's something that we're going to move around or that's going to move itself around, minimizing material weight, material volume, and so on. Other products have bigger impacts during the production phase. For example, things like carpet, where we're using a lot of solvents and a lot of petroleum products and so on. We're going to want to think about the impacts of those materials on employees, and can we pick better materials? Can we simply eliminate certain solvents, certain glues, things like that. Other products, particularly agricultural products, for example, the sourcing phase is really going to be the biggest deal. So we might want to think about things like local sourcing, sourcing inputs that have a lower water footprint, sourcing from regions that have plenty of water, those types of things. So it really depends. So the final thought on this, I think, is just concurrency. Again, the idea that we don't wait till we're done with a product or service to think about what we're going to do with it when we're done with it. We don't wait till the user is using the product to think about the impacts during the use phase. We'll do the best job that we can do if we consider all this stuff during the design phase, because that's when most of these impacts really become set and very, very difficult to change.